Okay, today we study about standard representation of logic function, which may be two-table mathematical expression in canonical form, which have canonical sum and canonical product. Okay. For the representation, we show the relationship between output and input. For example, if you write two tables, we show you input and output of the function. Here we write down for every possible value of input and show the output for each value of input. So you can complete to represent this one. Anyway, we also often represent the function in mathematical expression. Okay, before to do that, let's see some terminology. Literal is variable or variable with complement. For example, x prime or inverse of x, y prime. Product term is literal, okay, single literal like this, or product of two or more literal. For example, x and y prime and z, w prime and y prime and z, okay, and dot, okay, like multiplication. So we call it as product term. If we bring two or more product term sum together, you get sum of product expression like this. Okay, sum term is single literal or sum of two or more literal like this. If you bring many sum term and together, we get product of sum. Okay, and normal term is the product term or sum term with no variable appear more than once, namely for the normal person, maybe not write, for example, x 2 times, right? You write x only one time, or w or x prime or y, okay, w or w. For the normal one, okay, we write only one time. Okay, so this kind of expression is called normal term. Okay, now this is very important word and meaning that you must understand. This is midterm. Min is from minimum. Okay, midterm. Okay, we show you the term. For example, if your system have three input variable x, y, and z, and maybe output f. Okay, how many combination of the input value for three input variable? Of course, 8, right? 0, 0, 0, 0, 0, 1 until 1, 1, 1, right? For the value of x, y, and z. Okay, so the minimum case that make the output or the value of the function is 1 is called midterm. Only one case. Okay? Only one value of input that make the output to be 1. Okay? That condition or that expression is called midterm. So what kind of function that make the result to be 1? Only one case. Yes, and right? And function. So you should write the expression in and, right? And between all input variable. For example, if your function x, y, z is input, right? And output f. Okay. If the function f is x and y and z, okay, this function will be one as only one case. When input x, y, z is 0, so sorry, 1, 1, 1, right? Because 1 and 1 and 1, okay, is 1, only one case. For another combination of the input, for example, 0, 0, 0, or 0, 0, 1, or 1, 0, 1, okay? Okay, if you substitute this value to the input variable, the result will be 0, not 1. So this term, okay, is midterm. Okay? Midterm will be only one case of the input. Okay, another example. How about this? X, Y, Z, and output F. If the function is X prime and Y and Z, how about this? This function will be only one case when this literal, okay, the value of this literal is 1, 1, 1, right? So when what? When z is 1, right? When y is 1, and when x is 0, right? Because invert here, right? Invert of 0 is 1, right? So then it becomes 1 and 1 and 1, okay? So the result is 1, only one case. For another value of the input, for example, 0, 0, 0, or 0, 0, 1, and so on, 1, 1, 1, okay? Don't make this term to be 1. So this term will be only one case when the value of x, y, and z is 1, 1, 1. So this term is midterm. Okay, very easy, right? How about this one? So if you understand, so I think you can find midterm. If the midterm, okay, I want to make the function to be only one case when the input x, y, z is, for example, 1, 0, 0. Can you find it? Okay, of course, the midterm or the function will be only one case. That means you must AND, right? And all input variable. All of input. If you have 1, 2, 3 input variables, so you must AND all of this. But the result you want the input value is 1, 0, 0, right? For x, y, and z respectively, right? If you substitute 1, 0, 0, 1, 0, 0, 0 to x, y, and z, the result is not 1, right? How to make it to be 1? Yes, you must invert at y and z, right? So when you apply the value 1, 0, 0 to x, y, and z, so the result will be 1 and 0 prime and 0 prime, right? So it's 1, only one case. So the midterm for this input value is x, y prime, and z prime. Okay, let's more one example. X, Y, Z. How about this? If I want function to be only one case, when the input x, y, z is 0, 1, 1. How about this? Yeah, it's x prime and y and z, right? Okay, and all of this. For the input is 1, so you write that input variable without prime, without any complement. But the input 0, okay? that variable must have complement, okay? Must have invert. Okay, now let's consider this example. How about this? X, Y, Z, F. Sorry. If the function, or if the expression is X and Y, for example. Okay. If I want the function to be 1, of course, X must be 1, right? Y must be 1, right? So how many cases of the input X, Y, Z that can make output to be 1? How many combination? 1? No, not 1, right? Of course, this term will be 1 when X is 1, right? Y is 1. But don't forget that Z, okay? Z must have value, right? Z can be 0, right? Or 1, right? So this term will be 1, okay? Just X is 1, Y is 1. So 1, 1, 0 or 1, 1, 1 also make the function to be 1. That means this case, there are two cases, okay? Two combination input value that make function to be 1. That means this term is midterm or not. This term is not midterm. It's not midterm because there are two cases, okay, two combination that make function to be 1. By definition of midterm must have only one case that make output to be 1. Okay, so that means okay, the function must depend to all input variable. It will be midterm. But if lost or remove only one or more input variable, it's not midterm. Okay, because there are two or more, okay, case that make output to be 1. Another example, X, Y, Z. This term also, if F is X prime, for example, the output will be 1 when X is 0, right? Okay. How about YZ? The function is independent, okay, to the variable Y and Z, right? That means you can apply any value with X is 0. For example, X is 0, Y, Z is 0, 0, or 0, 0, 1, or 0, 1, 0, or 0, 1, 1, okay? There are 1, 2, 3, 4, okay? 4 cases that can make output to be 1. So this term is not midterm, okay? Not midterm. Okay. Okay, now I think you understand the meaning. Okay. So the midterm, okay, you might write in the normal, okay, product term with n literal. N mean all input variable. Okay, this is very important. And okay, this chart just show you some possible midterm for 3 input variable. For example, X prime, Y prime, Z prime. Okay, this term is midterm. This term will be just only one case when the input value is 0, 0, 0. Or this term will be just one case when X is 0, Y is 1, Z is 1. Only one case. That means when you apply the value of 0, 1, 1, 2, X, Y, and Z, the result will be 1. But if you apply 0, 0, 0, 1 or another combination value to this term will be 0, not 1. Okay, understand? Okay, and the value, okay, that make that midterm to be 1 is called midterm number, okay, or midterm I. Okay, you can express in decimal or binary form. Okay, next. max term. Max, I mean maximum. Okay. For example, for 3 input variable, there are 8, right? 8 combination input. Okay. The maximum case, but not all, that can make output be 1, of course, is 7, right? 7 case. That means only one case that make output to be 0. What kind of function that make the result to be 0? Only one case. Yes, OR function, right? OR function. Namely, for 3 input variable, for example, x, y, z, right? And f. Output f will be 0. Only one case. Only one case. That means the function must write in OR. Okay? Or all input variable. For example, x or y or z. This function will be 0 only one case. When x is 0, y is 0, and z is 0, right? So that means for another combination input value, for example, 1 1 1 1 1 0 0 1 0 and so on. Okay, 7 case. Make this term to be 1. Okay, make this term to be 1. Okay, 7 case. Okay, to be 1. But only one case that make this term to be 0 when the value is 0 0 0. Okay. This kind of expression is called max term. Okay, maximum case that make output to be 1, or only one case that make output to be 0. Okay, another example. So now, how about this? How about this expression? F equal to x prime or y prime or z. Okay, this term will be 0. Only one case, right? Because or, right? Or function. Only one case when what? When this term is 0, this term is 0, this term is 0, right? Altogether. So that means the value of x that make output to be 0 is 1, right? Must apply 1. Okay, 1 prime, it becomes 0. Y also is 1. Y prime is 0. Z is 0, right? So when you apply 1 1 0, okay, into the function, output will be 0, only one case. So this term then is max term. Okay. So how about this? X, Y, Z. If I want the function to be 0, only one case. When x is 1, y is 0, z is 1. Okay, can you write the expression for this? Yes, you can, right? So, at first, it's not 0, only one case, so it must write in all form, right? Some all input variable. And after that, you just consider this variable should have complement or not. Okay, for all function, it will be 0 only one case when this term 0 0. Okay, this portion must be 0, but you want to apply 1, right, to make this expression to be 0. That means you must add invert, right, into this variable. Y is 0 already, okay, right? Z is 1, right? So you must invert Z also. So your expression is x prime plus y plus z prime, okay? that will be 0 only when one case when x is 1, y 0, and z is 1. Okay, very easy, right? So this is max term. So if you know, so how about this? Let I change input to A, B, C, D, output F. If I want the function to be 0, only one case when input value is 1, 0, 1, 0. How about the function or max term? Yes, okay. At first, you may write in all form, okay, in some term first. After that, you just consider for all function, you want the result to be 0, right? So that means all of these variable must be 0, okay? Of this position, the value must be 0. But you want function to be 0 when a is 1. That means a must invert. B already 0, okay? C must have invert, right? To invert 1 to 0. And D already 0. So that's all. So the max term is this. Okay? A prime plus B plus C prime plus D. And how about this? Let's consider 1, 2, 3. Let I do x, y, z again, and f. If my expression is x plus y, how many possible value of these input that make output to be 0? Okay, how many combination of input? Yes, this function will be 0 when x is 0, y is 0, right? X is 0, y is 0. It's not depend the value of z, but when you apply the value into this circuit, you must apply the value of z also, right? That means you must apply 0, 0, 0 or 0, 0, 1, right? That means there are two cases, okay, two cases that make function to be 0. That means this term is max term or not? No, it's not max term, right? It's not max term because there are two, okay, two combination, two cases that make function to be 0. Okay, so this is not max term. No. Okay. To make max term, you must write in some term or all input variable. If you have 3, you must write all 3 input variable. Again, how about this? X, Y, Z, F. If your function is, for example, Z, how about this? The function will be 0 when input Z is 0, right? But when you apply the input value, you must apply all of this, right? That means you must apply the value of X, Y also. So maybe 0, 0, 0 for Z, or 0, 0, sorry, 0, 1, 0, 1, 0, 0, or 1, 1, 0. All of these 4 cases, Z are 0, right? So all of these 4 cases make function to be 0. That means this term Z is not max term. Okay, so to understand this concept, okay, you can pass this course easily. Okay, and for this chart, okay, just show you some possible max term for 3 input variable. For example, x plus y plus z, okay? X or y or z will be 0 only one case when x is 0, y is 0, z is 0, right? Only one case. Sorry. And for the term, for example, x plus y prime plus z. Okay, this term will be 0 only one case when x is 0, right? Y is 1, right? Z is 0, right? Okay, if you apply, oh sorry, if you apply uh, 0, 0, 0 to this term, okay, to this expression will be 1, or this one also, okay, will be 1. Okay, all of this, okay, will make function to be 1, except this value. This value will make this term to be 0, only one case. So we call this term as max term, and this value is called max term number or max term I. Okay, you can write it in decimal or binary form. And now that introduce one standard representation to represent the function completely. Let's consider this example. If function f is 1, 1, 1, 1, 1, how many cases? 1, 2, 3, 4, 5. Okay, when you apply the input x, y, z with 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, and 1, 1, 1. Okay, now to write down the complete mathematical representation of this function, you maybe use something like superposition in circuit analysis. So you consider or focus or concentrate only logic 1 output one by one. Namely, if you consider this function will be 1 when input is 0, 0, 0. That means you might think through midterm, right? This term will be 1 only one case. When x is 0, y is 0, z is 0. That means this term is what? Is x prime and y prime. Oh, sorry. This term is x prime and y prime and z prime, right? Right? To make this function to be only one case. Okay. Like this. After that, you just consider another logic 1 result. This one will be 1 when input x, y, z is 0, 1, 1. That means midterm is x prime and y and z, right? X prime and y, z will be only one case. Okay. For enter value of x, y, z, the result will be 0. And how about this? For this one, will be only one case. Now when x is 1, y is 0, z is 0. So it's x and y prime and z prime. Okay, be only one case. For this one, only one case that make function to be 1. The midterm is x and y and z prime. And this one, 1, 1, 1, x and y and z. So you get 5 midterm. 1, 2, 3, 4, 5. Okay, to make function to be 1 for each case. Okay, as shown in this truth table. Okay, now after that, you just add all, right? Sum of this midterm. Okay, this is all of this term together. The result will be the complete function. Namely, if you apply 0, 0, 0, this term will be 1. This term will be 0, 0, 0, 0. Okay, 1 or 0 or 0 or 0 or 0 is 1, right? If you apply 0, 0, 1, okay, this term be 0, this term 0, this term 0. this term 0, this term also 0. If all of this midterm is 0, so result is 0, right? When you sum all of this together. Okay, that means if you apply input that's corresponding to midterm, that midterm will be 1, okay, and another term will be 0. That means when you add, okay, all together, the result will be 1. But if the input that not make any midterm to be 1, namely all value of midterm are 0, so the result will be 0. Okay, that means now you can complete the representation, okay, or write the expression for this function. Okay, this kind of expression is called canonical sum. Canonical sum or canonical sum of product, right? Or canonical sum of midterm. Midterm is product term, okay, that have all input variable. So now you know canonical sum. You can write the function in this form. It's a standard form. Or you can write in with this symbol sigma, okay, and input variable, and its corresponding input that make function or output to be 1, like this. Okay, this term x, y, z, right, will be 1 when x is 0, y 0, z 0. Then you write 0, 0 at here. For this term, will be 1 when x is 0, y is 1, z is 1, right? So you write the value of x, y, and z with 0, 1, 1 at here, okay, and so on. Or you can write in decimal form, okay. But must be careful about the order of input variable. Okay, this kind is called a midterm list, okay, or on set. On off, right? On mean the result is 1. Okay, midterm list will list all input value that make function to be 1. Okay. And you can also consider logic 0 output. Again, if you consider already this one, you must think to max term, right? That make the function to be 1. Sorry, that make the function to be 0, only one case. So we think to max term. Okay, what kind of term that make function to be 0, only one case, when the input value is 0, 0, 1. Yeah, it's x or y or z prime, right? Of this 0 or 0 or 0, right? But this is 1, so you must invert this z variable. So this term will be 0, only one case. Okay, another combination value, okay, this term is 1. How about this? For this one, x is 0, y is 1, z is 0. So it's x or y prime or z, right? That can make function to be 0 only one case. What about this one? For this, x is 1, y is 0, z is 1. So max term is x prime plus y plus z prime. Okay. After that, you just and, right? And all of this max term together. So if one of this max term is 0, when you add to another term, the result will be 0, right? But if the input don't make any max term to be 0, namely of this 1, so when add together, the result is 1. Okay, and you want, okay, to implement the function. So this expression is called canonical product, okay, product of sum or product of max term. And when you write in this form is product of sum, or you can write with this symbol pi, right? Pi x y z, and the value that make function to be 0. You can write in binary form or decimal value. Okay, so you get max term list or offset. So now, if consider this one, if you write for the same system, this function will be 0. Only one case. When what? When input value is 1, 2, and 5, right? But there are 3, right? 3 input variable. That means there are 8, right? Possible value 0, 1, 2, 3, 4, 5, 6, 7, right? 0 to 7. For the value of 1 to 5, make function to be 0. That means the value input value 0 or 3 or 4 or 6, 7. Okay, when you apply this value into the input, the result will be 1, right? So you can write in this form, okay, onset or midterm list with this expression, okay, it's equivalent together. So that means you can convert, right, between this by consider all possible value. Okay, the value that make function to be 0, that means the left value will make function to be 1. So very easy. So the short relationship between midterm list and max term list. For example, for this example, there are 3 variables, right? That means all possible value is 0, 1, 2, 3, 4, 5, 6, and 7, right? But the function is 1 when input value is 0, 1, 2, 3, right? This make function to be 1, right? That means the left, okay, input value will make function to be 0. So 4, 5, 6, 7. And for these 2 variable, is maybe 0, 1, 2, 3, right? For all possible value in decimal, okay, of 2 input variable. But it will be 1 when the value is 1, right? That means for input value 0, 2, 3, make function to be 0. Okay, right in this representation. Or for this example, there are 4, right? 4 means 16, right? 0 to 15. Okay, for all possible input value. Okay, among this, for this set, make output to be 1. That means the left value, namely, what would be 4, right? 5, 6, okay, 7, 8, 9, 10, and 12, okay, 13, 14, 15, okay. Of this, you make function to be 0. And well, if I have the expression like this is canonical sum, right? All of this term is midterm. It's midterm. If I want to write down two table, can you? Yes. Okay, you just write all possible value of input first. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, right? And then you just consider when the output will be 1 only first. Okay, for this term x prime, y prime, z prime, okay, this term will be 1 only one case when input x, y, z is 0, 0, 0, right? So right here, right? How about this x prime, y, z 0, 1, 1, right? 0, 1, 1. Okay, x, y prime, z prime 1, 0, 0, 1, 0, 0, 0. How about this x, y, z prime 1, 1, 0, right? 1, 1, 0. And x, y, z, okay, will be only one case when input is 1, 1, 1. So after that, for the left, okay, will be 0. That's all. That means now you can write down two tables, okay, from this expression. This is the basic skill that you should have. And how about this one? Now you write in product of sum, right? So you must consider, okay, or focus on the result of logic 0. Okay, again you write down all possible input value 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1, right? And the output will be 0 when what? X plus y plus z prime. That means x, y, z is 0, 0, 1, right? So 0, 0, 1 at here. X, y prime plus x plus y prime plus z. So it will be 0 when x is 0, right? Y is 1, z is 0. So 0, 1, 0 at here. And this term, x prime plus y plus z prime. So this term will be 0 when x is 1, y is 0, z is 1. So 1, 0, 1 at here. And for another input, you give 1 as the result. Pretty easy, right? Okay, this is basic skill. Okay. Okay, now let's take a break about this. Okay, let's switch to circuit analysis. Okay, to analyze the combinational circuit. Okay, you want what? You want to analysis mean effort maybe some given circuit. Okay, you have got some given circuit and you want to know the relationship between output and input. And the result of analysis is something that show the relationship between output and input. For example, if you analysis by this method, okay, exhaustive method, namely you just apply all possible input value, namely for example apply 0, 0, 0, right, and you just consider 0 at here, invert, so it's 1 at here, 0 or 1 is 1, right, and 0 at here, 0 and 1 is 0. After that, for this invert, then it's be 1 at here, 0 at here, 0 invert, then it's 1 at here, and together result is 0. This 0, 0 all together, result is 0. Okay, for input 0, 0. After that, you find the second case of 0, 0, 1, okay, and do like the previous example. So you must do all this process for all possible input value. After that, you will be write the two table, okay, to show relationship between output and input. Okay, this kind of analysis is called exhaustive analysis. Maybe this method is suitable for computer. Okay, computer do this work. Okay, for us. Anyway, for human, okay, analysis maybe algebra is better. Namely, you just consider, okay, the result by keep in the variable name. For example, x is here, y prime is here, then the result of this R function is x plus y prime, and this is z, right? So, and together is x plus y prime and z, okay? And this one is x prime, y, z prime, right? So, what is output of AND gate then is x prime and y and z prime. After you all two term this together, you get the result of this function. Namely, is x plus y prime and z plus, okay, x prime, y and z prime. Okay, that's all. So you will get the expression, okay, to show the between output and input. Okay, this kind of analysis is called algebraic analysis. Okay, and okay, now from the result of analysis, if I want to implement the circuit in the structure of um, uh, AND or AND, okay, what should I do? Okay, let's consider this one first. If I want to transform this expression to sum of product, sum of product means there are many product terms sum together. Okay, sum of product. Okay, for each term is product. Okay, between input variable. That means, okay, how to arrange this expression. At first, for sum of product, oh, this term is already okay, right? It's product from, right? X prime and y and z prime, right? Is product term, so it's okay. But this term is not okay, right? It's mixed between sum and product. So what should you do? Keep this one, right? You just take this one, okay? Distribute. So then it becomes x and z, right? Plus y prime and z, okay? Plus this term, okay? Copy it. X, y, and z prime. Okay, that's all. Okay. Okay, by using this method, or sometimes it's called multiplied out. Okay, you will get the result of this process as sum of product. And based on this, okay, expression, you can write the circuit diagram like this: x and z. This one, right? X and z, y prime and z, y inverse, right? Y prime and z, x prime and y and z prime, x prime and y and z prime, okay? And these three terms all together, okay? So you get two level and or, okay? The first level is and, right? The second level is or, okay? And for this structure, okay, we will consider this inverter, okay? Just give the literal with complement. So we don't count this inverter as more one level, okay? For the input variable, okay? So we just consider this one. But if you have some inverted here, so now it's 1, 2, 3. Now it's 3 level. If the inverter, okay, that change the original input to input with complement. Okay, we don't count this one as the level of the circuit. Okay, and now okay, let's consider if what happens if I add two inverters at the same line. The result still be the same, right? Okay, not affected final result. So I can add this one pair of inverter. Okay, I can add pair of inverter. Okay, by maintain the result of the function. So what happened? Okay, let me write only circle to show the invert. If I move this invert to here and this one to here, so I add it here and here for this line also. Okay, invert. Okay, pair of invert, pair of inversion bubble. Okay, so you will get the same result. And now if you consider this one, now it's become NAND, right? NAND gate. This one also NAND, right? You remember? If you move this inversion bubble from input side to output side, and you change the body from all to N, so it become what? All to N and invert at the output, so it become NAND, right? NAND gate. That means now you can change to level and or to level NAND. Okay, so you can convert from the structure of two level and or to level NAND easily. Okay, by adding pair of invert. Okay, to this line between output of the first level and input of the second level. And how about this one? If I want to transform the expression to product of sum, okay, for product of sum mean I want to write in product from okay of sum term. So this is sum, okay, sum of literal or variable. So let's consider this one. For this term, okay, it's okay, right, for this part, but not okay for this one and for this one. So what should I do? Okay, I will keep this one like one module, right? After that, I do add out. Okay, this all right, add out this term or this term, and or this term and or this term. After that, this term z, okay, to this term or this term and this term. Maybe this term. Sorry, color to this term or this term that is become x plus y prime or x prime, right? And what? This term is block x plus y prime and y. Okay. After that, and what? X plus y prime and z prime. Okay. And then we do this one, right? Z and x prime, sorry, z or x prime, z or y, and Z or Z prime. Okay, for example. Okay, something like this. After that, you just simplify this expression. For example, x plus x prime is 1, right? Y plus y prime is 1, right? And what else? This one, right? Z plus z prime is 1. So we get the result of product of sum, by using this add out process. And from this product of sum, so this sum term using this OR gate, this sum term use this OR gate, and this term use this one, and then AND, right? AND of the three terms together. So you get two level OR AND structure. Again, if I add pair of inversion bubble or inverter, it should be the same result, right? Same line, you can add pair of inverter. So if I move this inversion bubble attached to this output, and for this side attached to the input, so it will be what? It will be what kind of logic gate? NOR, right? This is NOR. This one also NOR gate. So now you can change from 2 level OR AND to 2 level NOR. You can change it easily by adding pair of inversion bubble or inverter. Okay. And now you can synthesis, or implement the circuit in 2 level NOR or 2 level NAND, by transform it from 2 level OR AND or 2 level AND OR first. To get this structure, you must write in product of sum of product first. So that means to implement the computational circuit for the general process, maybe starting with thinking first, and maybe describe by using some word or some expression, mathematical expression, like this. After that, you want to make the circuit in 2 level NOR, so you must do something like add out, to arrange the expression to product of sum. After that, you can write the circuit in 2 level or AND first, and then convert to 2 level NOR. Or if you want to write 2 level NAND, you must arrange the expression to sum of product first, and then you can write 2 level and OR, and then convert to 2 level NAND. But if you want to make the circuit in another form, maybe you may use some truth table and using something, right, to get the algebraic expression. After that, you write the schematic or circuit diagram. After that, you implement and test and modify the circuit. But to reduce the cost, you must reduce number of variable, right? Number of operators. Namely, you must reduce number of logic gates. So now, how to reduce? Here, this is the point of this chapter. Namely, not only obtain the function that work as you want, but you must implement the circuit with the lowest cost, okay, the lowest cost, okay, if possible. Okay, now let's consider this example. If I want the function to be 1, okay, when the input value n2, n3, n2, n1, n0 is 1, 2, 3, 5, 7, 11, 13, okay, for this one, and 0 for otherwise. So what should we do? Yes, I can write in this form, right? In midterm list, okay? If I consider logic 1 output. So for this one, for example, 1 because of 4 input, right? So you can convert in decimal form to binary form, right? 1 is 0, 0, 1. So midterm of this is n3 prime and n2 prime and n1 prime and n0, right? How about 2? 2 is 0, 0, 1, 0, right? That means you must add more term of n3 prime and n2 prime and n1 and n0 prime, right? For this value. And for 3 is 0, 0, 1, 1, right? That means midterm of this is n3 prime and n2 prime and n1 and n0, okay, and so on. So you just find out all of midterm, and sum them together, then we get the equation, for this function. After that, you just draw the circuit diagram, or schematic, to implement the function easily, right? So you can make any circuit with this method, but this method is okay, but not so good because it uses a lot of logic gate, a lot of input, for each logic gate. So for the better circuit design, you must obtain the same function with smaller size of the circuit. This is the point for this class. Before that, let's introduce some basic skill about circuit manipulation. How to convert. For this one, you already know, right? Maybe if you write in sum or product form, you can implement circuit in 2 level and or, and then if you add pair of inverter, for each line between output and input, so you can get 2 level NAND, and if you write the expression in product of sum, so you get 2 level or AND structure. And then if you add pair of inverter for each line, so you get 2 level NOR structure of the circuit. And some condition, for example, if I want to use only NAND gate and inverter, to implement the function of A prime and B and C prime, or A or B prime and C prime, and D prime. Okay? Use only NAND gates and inverter. Cannot use or cannot use and, okay, and so on. Okay, what should I do? Okay, this kind of problem, okay, let you write down the circuit. Follow this expression first, okay, directly, like this. After that, you just consider, okay, how to change each logic gate to NAND. Maybe by adding pair of inverter for each wire or for each line. For example, if I add invert at here, okay, pair, right? Pair of inverter, so it's to be the same result. Then I add more at here, same result, right? Now this one is NAND already, right? Become NAND gate already. Okay, this one also NAND gate already. This one also NAND gate already, right? How about this one? If I want to change this all to NAND, that means I must add inverter at the input side, right? So, but this one, okay, this side already have one inverter, so I can add this one. And don't forget you want add pair of inverter, right? So now, when you group these together, okay, you can change all to NAND. So that's all, okay, to complete or finish this one. Okay, based on this example, so now you can implement the circuit by using only NAND gates and inverter. Okay. Anyway, if we want to reduce number of logic gates, okay, actually we can do more. Okay, at first let's consider this one. If this is signal A, and there are and there is inverter here. Let I write in only in version bubble right here. Of course, then it become a prime at this end and at this end, right? So what happened if I move this invert, okay, to, for example, to this one? Of course, this end still be a prime, right? But this end is a, okay, different result. If I want to keep the result for both ends, that means I must add circle right here, right? Okay, I must add inverter at here. So that means two of this is the same or equivalent. So now let's imagine if you move, okay, this inverter, okay, and then for this junction, okay, will be, okay, change from 1 to 2, okay, 1 to 2, okay, you can separate from 1 to 2 and become this, okay, then you get the same result, A prime and A prime at here. Understand? Or actually it's the same, but I just show you something like this. And if the input at here, this point is A prime, this point is A, right? So if I want to move this one to be here, what happened at here? So now A prime is here, right? But I want to keep this point to be A also. Now it's A prime at here, right? So what should I do? I should add invert at here. So when I add invert at here, now this point is A, right? Same like this. That means I can imagine that I move this inversion bubble, and then for this junction, okay, it's separate from 1 to 2 inverter. So that means now I can move this. I can move this to this point and then separate to 2 inverter. And for this one, we cancel together. So now we left only one edge here. Okay. Finally, we can use uh, minimal of logic gate to implement this function by using only NAND and inverter. Okay, that's all for today.